Hello, welcome. We have a polynomial equation and we need to solve for x. They have given to us in the bracket x plus 3 power 4 is equal to 16. Since this polynomial has a highest power of 4, it has 4 roots. The mistake they used to make is they consider this as x plus 3 power 4 is equal to 16, and they make it as x plus 3 power 4. 16 can be made as 2 power 4, and a power b is equal to c power b. Now, since the power are the same, the base are the same, and they end up say a is equal to c. For that case, x plus 3 is equal to 2. X is equal to 2 minus 3. I get x is equal to minus 1. It is true that x is one of the root, but they miss other 3 roots. So we are going to rectify that problem. Let's go to our solution part. We have x plus 3 power 4. This is equal to 16. I'll bring 16 to the left-hand side. That is going to be x plus 3 power 4 minus 16. This is equal to 0. I'm going to make x plus 3 power 4 minus 16 in the difference of two squares. That is a square minus b square is equal to a plus b in the bracket a minus b. X plus 3 power 4, I can write it as x plus 3 square in the bracket square minus 4 square. This is equal to 0. We know if we have a square minus b square, this is equal to a plus b, a minus b. For that case, x plus 3 square minus 4, x plus 3 square plus 4, this is equal to 0. This is the form of a multiplied by b is equal to 0. So a is equal to 0 and b is equal to 0. X plus 3 square minus 4, this is equal to 0. And x plus 3 square plus 4, this also is equal to 0. Let us take the first one, x plus 3 square minus 4 is equal to 0. This is another difference of two squares because I can put 4 in the form of 2 square. That is x plus 3 square minus 2 square. This is equal to 0. X plus 3 plus 2, this is equal to 0. And x plus 3 minus 2, this is also equal to 0. Let's take the first one, x plus 3 plus 2, this is equal to 0. We get x plus 5, this is equal to 0. Now x is equal to minus 5. Let us find another root by using x plus 3 minus 2 equal to 0. I'm going to open the bracket. X plus 3 minus 2, this is equal to 0. That is x plus 1 equal to 0. We get x is equal to minus 1. Remember, we have another factor here that we didn't work on. That is x plus 3 in the bracket square plus 4 equal to 0. I'm going to open the bracket. That is x plus 3 square plus 4. This is equal to 0. I'm going to expand x plus 3 square. That is going to be x square plus 6x plus 9 plus 4. This is equal to 0. That will give us x square plus 6x 9 plus 4, we got 13. This is equal to 0. Let us test for discriminant if we have a real root or we have a complex root. A is equal to 1, B is equal to 6, and C is equal to 13. Discriminant is given by B squared minus 4AC. Now this is equal to B equal to 6, that is going to be 36. Take away 4 multiplied by A, which is 1, multiplied by C, which is 13. 4 multiplied by 1, multiplied by 13. We get 36 minus 4 multiplied by 1 multiplied by 13. It is 52. Since the discriminant is negative, we are going to get a complex root. Let us solve x squared plus 6x plus 13 equal to 0 by using general formula, where a is equal to 1, b equal to 6, and c equal to 13. Let's substitute our values to our general equation. Now x is equal to b equal to 6, that is going to be minus 6 plus or minus square root of 6 squared minus 4 multiplied by a is equal to 1 multiplied by c, which is equal to 13. This is over 2 multiplied by a, which is equal to 1. X will be equal to negative 6 plus or minus square root of 36 minus 52 over 2. X is equal to minus 6 plus or minus 36 minus 52. We get under root of minus 16 over 2. Now x is equal to minus 6 plus or minus square root of minus 16. We get 4i over 2. X is equal to, by 2 we get 1, here by 2 we got 3, and here by 2 we got 2. Now x is equal to 3 plus or minus 2i. So our four roots are x is equal to minus 1, minus 5, and 2 complex root, that is 3 plus 2i, and other one 3 minus 2i. This is our roots. Thank you very much for listening. Don't forget to subscribe, share, and comment to this video. See you next time. Bye.